Hello everyone, I am Sudarshan. Now I am going to teach the topic of BIOT SAVART law. Let's start. What is BIOT SAVART law? Let us start right now. Suppose when the current is flowing through the conductor like this is the conductor, and the current is flowing through the conductor, and the current is nothing but it is the change of charges per unit time, the flow of charges per unit time through the conductor. And here the free electron or valence electron of the conductor is drifting toward the higher potential, and when it drifting toward the higher potential, it is with the drift velocity, that is E electric field free electron tau upon mass of electron. This is the drift velocity of the electron. When the charge is flowing through this conductor, there will be huge order of acceleration or retardation takes place. When the electron is retardation toward the higher potential, toward the higher potential, its retardations or accelerations of free electron, its order is 1.76 into 10 to the power plus 11 meter per second square. Whenever the charge is accelerating toward the higher potential, in the time the magnetic field produced around it, like this. Magnetic field around it, all around it. This is the magnetic field, and this magnetic field line or magnetic flux liberate or spread around the conductor, and the magnetic field line is perpendicular to the conductor. Suppose this is the conductor and this is the length of elementary length of the conductor, and this is the elementary length of the conductor, then this is dl, and the current is passing through this dl. Then at a distance r, we select a point P. Here the magnetic field is produced, that is dB. dB magnetic field is produced due to current carrying conductor dl, current carrying conductor dl. This is the elementary vector length of the total length L. Whenever the current is passing through this conductor, then produce a magnetic field according to BIOT SAVART law. But the current carrying conductor element, that is dl, the magnetic field produce dB, and this dB produce magnetic field perpendicularly to the distance of this one, this current conductor length, and dB, this dB which is produced by the current conductor is directly proportional to the flow of current over this conductor of length L. So this is the equations, this is the directly proportionals. We know that the current is flowing through these directions, and this is the flow of charges per unit time. Whenever the charge flowing through the conductor, then the current will be there. Whenever the current will be there will be the magnetic field. And if we taking a small dl, then its magnetic field also dB. Magnetic fields all around this, and this is called dB magnetic field. And this dB magnetic field is directly proportional to the current. The current is higher, then its dB will be increased. Current is decreased, then dB will be decreased. So this is the directly proportional to the current, that is I. And dB is directly proportional to the dl. This is equation 2. When the current is passing through this, then dl with the elementary area. This is suppose that dl. This is the L, this is the conductor, and this is the dl length, dl, and current is passing over it. Then in the magnetic field, this is the magnetic field around it, magnetic field around it at a distance r, at a distance r, at a distance r, at a distance r. This dB is directly proportional to the dl. dl is dl length elementary, then its magnetic field will be elementary. When length is L, then magnetic field will be P, all around the conductor perpendicularly, because we know that dl is integrated, dB is also integrated, and then after integration of this one we get L, after integration of dB we get B. So full length, the magnetic field throughout the conductor, that is length L, its magnetic field will be B. So the dB, length dB, current conductor length dl, the magnetic field is produced due to current conductor dl. Magnetic field will be maximum, then length should be maximum. Magnetic will be maximum with respect to the dl, depend on the dl. So it is directly proportional to the current conductor dl. dB, dB is directly proportional to the sine theta. This dB is sine theta like this. Suppose the conductor is like this, conductor is like this, and this is the elementary area. We are taking the elementary area. After getting the elementary area value, we get the total length after integration of this elementary length. So suppose this is the elementary area and elementary length, then its magnetic field is like this, dB, and this magnetic field at a distance r, all around the conductor of dl length, that is perpendicular to the dl length. So this is perpendicular, this is 90 degree, and here the 0 degree, this is 0 degree, this is 30 degree, this is 45 degree, this is 60 degree, that is 70 degree, and 80 degree, and last 90 degree. The maximum angle max 90 degree from 0 to 90 degree, then its values varies from or range from 0 to 1. This is max value and this is 0, minimum value, min value. So you can say that and we understand that the sine theta 0 degree is give value 0 and sine 90 degree gives value 1. So its values from 0 to 1. So it is 0 and maximum value is 90 degree, and all the magnetic flux line, electromagnetic field line is perpendicular to the dl length. So its sine theta will be there. Due to the maximum values range from 0 to maximum 1 to 0, the cos theta will be here. Cos 0 degree, its value is 1 and cos 90 degree is value is 0. So we cannot put here cos theta. So sin theta gives the value from 0 to maximum 1. So dV is directly proportional to sin theta, and dV is inversely proportional to the r square, and this is equation 4. R is the distance between point P and elementary length dl. This is the conductor and this is the elementary length dl. Suppose this is the point P and this is the distance, perpendicular distance r, and the magnetic field is like this, all the perpendicular distance. This one, magnetic flux is liberated. So this distance is inversely proportional. If the point is increasing, then it's the dV will be decreased, and it is the round shape. Always remember that it is a round shape, then it is r square. We know that in the circular shape the area is, suppose this is the r and it is area is directly proportional to the r square. So we take a round shape in the circular like shape and at dl length. Suppose we take a total full length and it will be the cylindrical shape like this. This is like the cylindrical. Cylindrical. So it is a elementary part. This is the elementary part and this is called dV, and this dV is we have to find at point P. When the point is increasing or far away from the dl length, then the magnetic field dV will be decreased. It is inversely proportional to the r square. So after combining equation 1, 2, 3 and 4, we get, after combining equation 1, 2, 3 and 4, we get dV is proportional to I dl sin theta upon r square. and we remove out the proportionality constant, that is mu 0 upon 4 pi and I dl sine theta upon r square. This is the BIOT SAVART law. This is the BIOT SAVART law. This is called BIOT SAVART law, and mu by 4 pi, mu naught by 4 pi is known as proportionality constant. Here, where mu 0 over 4 pi is called proportionality constant, or proportionality constant. We know that when the magnetic field is like this, magnetic field is produced around the conductor, there will be the permeability, and here permeability is represented mu naught, and 4 pi, this is the circular shaft, this is the circular shaft, suppose, and this is dl, suppose this is a dl length, and this angle is ds area, and this is dl length, and this is the all around the conductor, all around the conductor, whenever current is passing through it over the dl length, then its area is this one, and here is the solid angle. This is radially outward direction, and it is a solid angle, and this is called d omega, and its value is d omega, and it is, when integration, this total is the 4 pi solid angle. So we write here, this is the elementary part, but here is the cylindrical shaft. So we write here, this is like this. This is the unit area, this is the unit area, all the unit area. In that unit area, that solid angle will be 1 upon d omega. So we can calculate that this is this d1 by d omega, that is elementary unit area. The magnetic solid angle will be 1 upon 4 pi, and this 1 upon 4 pi, and this, when the magnetic field line produced all around the conductor, and in that case there will be the area like this. This is known as permeability due to the magnetic field line. This area is called permeability due to the magnetic field line. So when we combine this permeability to 1 upon 4 pi Pascals, then we get the proportionality constant. This is the proportionality constant after remove the proportional. So we get here, this is the equation 5, and equation 5 we can write in the vector form. Equation 5 we can write in the vector form. This this is mu 0 upon 4 pi I dl sin theta upon r square. This is unit. Here r unit is known as vector position of mod of vector position. So we put the value of unit vector, then we get dv mu 0 upon 4 pi I dl r square sin theta upon r cube. This is the another equation. This is the another equation of the BIOT SAVART law. This is the another equation of BIOT SAVART law in the vector form. When we put the value of maximum at sin theta, then we get the another equations and then simplify this one, then we get one like this. We can write this dv is mu 0 upon 4 pi, that is I dl. This is I dl, that is mod of, this is, you can say this one, and sin theta. So this is r cube. We know that this length, this is the conductor, and this is dl length. It is current is flowing through these directions I, and this dl, and we select a point P. At point P, it is perpendicular to the length dl. This is, and this one, this dl, this is r perpendicular to dl. The angle will be 90 degree. So here sin theta, there will be a cross product and vector form. So mu 0 4 pi this I dl into r vector upon r cube. This is dv. This is dv, and finally we can write it like this dv. This is dv, that's mu 0 4 pi I dl upon r square. This r and one r will be cancelled, and then we can write like this. This is the vector form of the BIOT SAVART law. This equation is 6, and this equation can be write 6a. So this is the another equation in the vector form. Hopefully you would understand about this. If you have any confusions, then I make you understand more time. Thank you for watching this video.